selected the right speaker for audio output. Test your speaker to ensure it is working fine from the audio settings option on the lower left corner of your screen. If necessary, dial in using phone.
Hello everyone, I'm Umesh, your host for today's webinar. Thank you for joining us in the second episode of our exciting series on cloud. I welcome you all on behalf of Harbinger Systems. This will be about a 45-minute session with maybe about 10 minutes. We'll take it at the end for questions from audience. Feel free to type in your questions in Q&A box. Getting it right the first time itself was the focus of our very first episode of the series. The Getting Your Cloud Right series promises to cover all the important aspects of cloud, whether you are adapting to the cloud or you're simply migrating to hybrid environment or optimizing your production, right? Irrespective of what phase of your cloud adoption you are in, it's indeed a significant challenge to identify where and how the costs are going up. The reality is that cloud customers pay for what they order, but they most often don't use. The result is that one may pay for resources that are unutilized or lying idle. Gartner estimates about 70% of the cloud spend was wasted in organizations worldwide. Whether you are an engineering leader, maybe a cloud product owner, or a CTO, escalating cloud spending may probably be one of the top challenges that may be on your mind. So we picked up cloud cost optimization as a theme for the second episode. Today, I have with me Abhijit Gokhale, Senior Architect at Harbinger Systems. Hey, hi, Abhijit.
Hey, hi, Umesh.
Abhijit, Abhijit heads the Center of Excellence that focuses on cloud engineering and HR tech practice. He has more than 11 years of experience in enterprise application design and very much possesses hands-on expertise in cloud computing, performance, data security, and system integrations as well. So welcome, Abhijit. Glad to have you here.
Same here, Umesh. Thank you.
Right. So Abhijit, continuing to our conversation from the first episode on right things to do, I would say, before we get on to the cost aspect, would like to talk more about the performance part. And the performance objectives play a crucial role in planning the costs, right? So if you can walk us through the specifics of right things to do for ensuring good performance of cloud applications.
Certainly, Umesh. So in our previous episode, we talked about like monitoring and measuring at different points in the deployment architecture to ensure that the application is meeting the required performance expectation. We also touched upon, bringing the design time focus on the performance to ensure that we are able to specify the performance constraint at individual components within the application. So in today's session as well, I will talk about how do we measure the performance of the cloud application, and I'll be doing that with certain examples.
Yeah, that would be good. Yeah.
Sure. So before we get into the performance measurement aspect of it, so the good place to begin would be to understand how user sees a application performance. So in terms of the user perspective, let's try to understand it. So all of us today, when we look at the application performance, we expect that whatever action we perform with respect to the application, it has to be, the response has to be given within a second or two. Sure. Like there could be some exceptions wherein we can see the file download type of a scenario may take, which is accepted, taking a time, but still even in that case, we will expect that the downloading at least should begin from the initial second itself. So if we look at the actions that user perform within a particular application, so that way, there are many requests which are being sent to the components which are hosted on the cloud. The responses of these requests are assembled by the components which are kind of executed within the device which user is using. So that way, these are nothing but the concurrent sequence of HTTP requests, which a single user action, kind of consists of. And the overall latency can be determined the sequence or the request which is taking longer time to respond. That will actually determines the overall latency of the particular user action that is being taken. Okay, so let's try to understand what constitutes to the different factors of the response time for a particular user action. So we can say there are primarily three elements. The first one is the time taken by the application components that are getting reside on the user's device. The second one is time taken by the components which are hosted in the cloud. And third one, obviously the time taken for the data transfer between these various components. So that way we can determine the overall response time by understanding the time taken by individual components which contributes to a particular action. Now, in such scenario, we can ask ourselves three questions. The first one is the user action is getting completed within the accurate time? So whatever is defined as the good response time. Now, in case that is not happening, then in that scenario, do we have the enough details about time taken by all the components which contributes to the user response? And similarly, the third question could be, in case of a poor performance, how do we use these measures to determine or to identify which component is contributing to the larger response time?
Okay. So yeah, I mean, these are key questions. So you're saying that we should focus on user actions and measurement of time taken by these constituent components for completing those actions. So now, I mean, how do we really go about measuring it?
Sure. So when we talk about the overall response time, we are saying that we need to identify the time taken by individual component. And when we measure the time at each component, basically we will kind of monitor all the requests that are getting served or delivered through that particular component. Now, it totally depends upon where and how this component is deployed in the cloud and what sort of metrics are available for the measurement purpose. Now, the cloud providers, they kind of provide the tools which can help us in analyzing the various metrics. Even there are third-party APM tools like New Relic are available, which helps us in monitoring the overall performance of the application. So let's take a look at three deployment scenarios where we can see how one should go about measuring these metrics. So in the first scenario, it talks about a API gateway and the actual functionality being delivered by a single function, which is backed in by the API gateway. So in this case, like even if we measure the metric at the gateway level, we'll able to get the overall response time for that particular function. Now, if we move to the second scenario, which is kind of a variation to the first scenario, wherein we are saying we have an API gateway, but now we have the chain of functions. So for a single action, there are multiple functions involved. Now, in this case, if we monitor the metric at the gateway level, we will get the overall response time, but we will not able to identify the time taken by individual function. So here, the metrics at the function level will be important. And the third scenario, where we are saying we have the infrastructure as a service-based type of implementation. And these type of scenarios, we normally see the HTTP request logs are the primary element of the measurement. But apart from that, in case we want to actually get to the component level, how they are contributing it to the entire user action response time, then we should look at the code instrumentation. So again, like the APM tools provide the code instrumentation, which helps us determining the key insights into the time taken by individual components. And similar sort of tools are also provided by the cloud providers. Okay, so let me walk you through with one of the example, um, uh, where I'll talk about like how these various cloud metrics will help us in not only managing the performance of the application, but also eventually come up with the strategy to optimize the performance. So this particular application was following the microservices-based architecture, and it was hosted on Amazon AWS using the serverless components like API Gateway and the Lambda. Now, during the performance verification stage, it was observed that one of the core functionality of the application was taking more time as the user load increases. So in the initial analysis, the metrics were analyzed at the gateway level. So, so those metrics were involved like the latency metrics, 4xx, 5xx errors. Apart from that, we also looked at the X-ray service map for that particular core piece of functionality. Now, this matrix initially helped us to narrow our focus, or rather to identify the API which was contributing more to the response time. Now, once we have the particular API identified, which was contributing more, the next logical step was to analyze the X-ray trace of the functions which are getting executed, Lambda functions which were getting executed through that particular API. So the initial trace was observed to determine if the cold start is one of the factor which is contributing to the larger response time. But after monitoring the X-ray trace, it revealed that that is not the cause of the increase in response time. So subsequently, we went ahead and further looked at the CloudWatch logs of that particular Lambda. And that actually helped us in revealing that the database operations are the major cause of the increase in the response time. As a next step, we then went into the monitoring of the database log. So in this particular scenario, database hosted was on RDS service of AWS. So we looked at the enhanced monitoring logs of RDS, and that helped us to determine like the read operations are causing more time compared to the write operation. So this way, eventually we'll able to derive the entire strategy wherein we able to optimize the performance of the application by ensuring the read operations time is optimized.
Okay, so this is interesting. So now, as you mentioned, APM tools here. So maybe let's get a little deeper on that. So you talked a lot about time measurement to ensure that user response is within the acceptable limits here. So, but we also have measures like CPU usage and IO network and data transfers and so on. So are they playing any role here as well?
Absolutely. Yeah, and before getting into the CPU and the other metrics, just one more point to highlight is like on the code instrumentation side of it, like, we have the APM tools available, and even there are now tools provided by the cloud providers, which help us in monitoring the client side performance as well. So we just don't have to monitor the our backend services performance, but if we look at holistically, we're able to monitor the performance of end-to-end user action using the client side monitoring.
Yeah, makes sense. More of a user perception of the whole performance.
Right. Yeah. Right. So yeah, coming back to what sort of role the CPU, memory, and the other metrics would play. So definitely, they have important role. So once we identified the component which is contributing more to the response time, the next step is to determine like what is causing that delay. Okay, so definitely these sort of metrics helps us in identifying the reason for the delay. So if we look at what could be the potential reasons for the CPU, the memory consumption getting increased, the two possible reasons could be either we have an inefficient algorithm which is getting executed by the component, or component could not get access to the resource, that is the processor itself. So the first scenario could occur uh, in case like for that particular period when the response time is higher. If we observe that only this particular component is present and no other components are running during that duration, then definitely the reason being the inefficiency of the algorithm. But if we observe that during the same time there are other components also which are running, then it could be a likely case wherein the components are competing for each other for the processing time. Now, in such cases, like cloud providers has the mechanisms, the alerting mechanisms, which help us notifying as well as taking the appropriate actions based on these metrics. Now, if we look at the network speed, now specifically in the cloud context, ideally the data transfer speeds should not be a constraint, or that should not be a major challenge. But when we talk about speed, we should look at what sort of data size is getting exchanged through the request, because that is something is the main cause of the latency. And in such cases, we have we need to monitor metrics like the data size process, and there are other metrics available which can help us in determining the latency related to the network.
Okay. Yeah, I think this gives a fair idea in terms of the details involved in getting the performance engineering aspects into maybe in the development right way, right? Now coming to the core part, that is the cost of cloud, and if are there any more of a systematic methods backed by these measurements that one can apply?
Sure, definitely I agree that cost needs to be focused upon. And even in Harbinger, we have seen cost discussions coming more frequently in recent times. Now, from the cloud provider's point of view, they provide tools and which can help us in, or even the recommendations in optimizing the cost. Even there are third-party tools available which can specifically focus on or assist us on the cost optimization. But since we are talking about the cost, first try to understand like how do we measure a cost of a cloud resource. Okay. So for any of the cloud resource, we can apply this particular formula. So wherein the cost of a cloud resource usage is nothing but the consumption of units of that particular resource multiplied by the price of the resource. So in this case, when we talked about the measurement at the consumption level, so the unit can be different. It can be time. So depending upon what type of resource it is, it can be time, size, or even in certain cases, the count of executions. So the cost of cloud deployment depends upon multiple factors. It could be the resource usage time. It could be the duration for which the resource is active, or the number of times it was used, and definitely the price of the resource. In terms of the computation side of it, like it varies depending upon the time or the volume or even the usage count. So when we look at the different resources like compute, storage, database, these type of resources, what we see is based on the characteristics of a resource. So for a compute resource, we will look at the CPU size. Let's say for a storage type of a resource, we will look at storage type, storage size. In case of a database, we will look at the read and write operations, so on. So that way, like, let's look at with an example with respect to the compute and storage service uses. So in case of a compute service, we will notice that on-demand cost of a VM instance is based on the user's time, and the cost is listed is per hour basis. So what we are saying is, for a compute resource, the time for which the resource will be active is the cost of that particular resource. So we can term it as billed for the time the resource was active. Now, if we look at in the contrast to the storage part of it, in case of storage, we can say that we make certain agreement that for a certain size of a storage, and with the duration, along with that, there will be the involvement of the snapshot. So in terms of snapshot, it could be the snapshot per month, as well as the size of snapshot, the number of IO operations. In certain cases, there is some limit which is freely available. But if we go beyond that limit, there will be cost associated to it. So there will be various parameters based on which the storage cost, the storage resource cost would be computed. So that way here we can just simply say that the billing uses multiple parameters, and many of which are difficult to estimate while making the choices about the resources that we use. So looking at these variations in the cost, one can say that like while deciding a particular resource, one will go with some sort of a optimal, instead of going with the optimal approach, they will kind of ensure that at runtime there should not be failures, and that way they will be kind of having more number of resources, or the higher resources than the optimal one which is needed.
Okay. So, so for making those choices, I mean, it's a difficult one, but businesses have to keep the cost in control. So how one should go about it? Are there any examples to explain that?
Sure, absolutely. So before talking about the example, let me talk about like what could be the common reasons for the higher cost. So the first one could be like we choose a more expensive resource type than one which is optimum for the given requirement. Another could be like the resource was selected properly, the resource type, but then we went with a higher configuration for that particular resource. And the third could be like the resources was active for the longer period than it was needed. So these are some of the common reasons. Now, since we are talking about the cost, if we consider in terms of the cost management framework, and if we apply that to the cloud cost management by tweaking it appropriately, we will certainly observe that we will come up with the good practices for managing the cost. So when we look at the cost of a resource, we say that the cost of a resource is nothing but the price of that particular resource and the number of multiplied by the number of units of that resource. So when we talk about the cost optimization, we have two options with us. Either we have to reduce the resource usage, or we simply have to reduce the resource price, or both, depending upon the scenario that we run into. Now, let me take one of the cloud application example and walk you through how we can go about measuring the cost as well as eventually come up with the optimization strategy.
Yeah, that will be useful.
Sure. So in this particular example, before getting into the deployment architecture, just a bit background about the application. So as the product uses, so this particular architecture gives us the view how the web resources consumption was increase once the product got developed. So initially, the product description or the testimonials were hosted on a one of the server, and as part of that, like it was also consuming some of the product features. Since the product is making use of some of the AI components, there were some AI components which were deployed separately on one of the CPU server. And the one of the AI component which was kind of processing intensive, that was got deployed on the GPU server. Now, in this particular scenario, like all the businesses, when we look at the financial report for this particular product, the cost usage was kind of monitored, and it was noticed that the cost is cost consumption is higher. And looking at the product overall roadmap and even the popularity, it was crucial to identify the optimization so that it has the good roadway ahead. Now, from that point of view, we started analyzing the particular application. Now, when we decided for the analysis part of it, we try to map it with the cost management framework, which we just discussed. So in order to reduce the cost, basically we need to reduce the right-hand side, which is nothing but either we need to reduce the resource utilization, that is the usage of resource, or we simply need to reduce the price of the resource. And to start with this particular analysis, we the approach that we taken was analyzing the cost from the cloud cost management, and we looked at so instead of going line by line for each of the item and then determining or rather trying to apply both these points for each of the line item, we kind of took the approach where we tried to see which is the component within that line item, the cost line item, is contributing more towards the cost. So this sort of a cost matrix helps us in revealing that the virtual machines are the primary factor or the primary line item which is contributing to 75% of the overall cost of that particular cloud cost for that particular product. So once we identified, next thing, we went into the uses of this particular virtual machines. So in this case, we first of all identified how these machines are provisioned. So all the three virtual machines are provisioned based on pay-as-you-go type of a price model. And the billing showed that they were active for the entire month, and we checked several months billing for that. So then we looked at the contribution which was made by individual VM to that 75% of the cost, and this was the distribution. So just by looking at it, one could feel that if we simply could eliminate the GPU server, with that will gaining up 50% from that, obviously from that 75% in the cost improvement. But before making any choices, one need to understand like how the application functionality is and what is the needs of that application. So in this particular scenario, when we looked at it, we observed that there were certain AI components which needs to be which were kind of processing intensive, and for that processing power, definitely GPU server was needed. So eliminating that would not be a good option. Then we looked at like how do we reduce the cost. So for that, we look at, is it possible to reduce the utilization of the CPU? So when we try to look at in the context of VM, we can say the utilization can be reduced by um, either by eliminating some of the VMs, or if we can, let's say, shut down some of the VMs and reduce the active time of it. So for that purpose, we try to analyze the CPU utilization at the 95 percentile statistics. So this particular graph helped us to determine like both at the GPU as well as the CPU level, which ones are contributing more. And that way, this revealed that at least for the GPU, for most of the days, the consumption was lesser. So it was not using its potential. Uh, and even on the CPU side, though it is lesser compared to GPU, it was higher. So this helped us in determining that since we were not able to eliminate the GPU component, would it be possible to shift all the components of the CPU and host it on the GPU? So once we check the feasibility of that at the technical level, that help us in gaining the improvement on the cost side of it. So overall, like we ended up saving 50% of the VM cost, which meant in the 38% to the overall costing of it. Now, if we look at this problem in the context of if we are able to reduce the cost by reducing the price of the resource. So when we say the reducing the price in case of VM, can we go with the VM with the lesser expensive configuration, or can we look at the different pricing options? So since the VMware provision using pay-as-you-go model, can we provision them using a reserve instance or spot instance type of a thing? So the first option where which says that can we go with the VMs with the lesser configuration. So definitely in case of CPU, it was possible, but the optimization strategy that we applied, wherein we eliminated the entire VM itself. So definitely, the cost saving was much higher compared to this particular option. And similarly, like if you look at the other pricing options, like reserve instance or the spot instance. So spot instance is definitely not an option for in this particular product scenario, as we cannot shut down these machines at any point of time. And the reserve instance means that we have to commit for a cost either 1 year or 3 years, depending upon whatever duration we are going ahead with. And since this was the beginning of the product, like and again that depends upon the where the product is, at which maturity is, and based on that the choices can be made. So the point is, the simple example like this can brings out various aspects that can talk about the overall cost optimization.
Indeed, I think thanks, Abhijit. You have like walked us through various finer details of the whole optimization process here, and I'm sure there are some key takeaways from this. I would say we have to list those 4 or 5 crucial aspects from the resource strategy point of view, then we would definitely say that identifying the unused and unattached resources, consolidating the underutilized ones, making sure that you have right sizing of those resources, and interestingly, like looking at the alternative prices for those resource options. And finally, I think the important aspect could be the whole DevOps readiness in terms of how well the infrastructure provisioning and automation process will ensure that we are leveraging the resources in an optimal way as well. Okay, I think we covered very remarkable points here, and maybe we'll pause now as we might have some curious questions waiting from audience here. So before that, let's take a poll that will help even Abhijit to respond to some of the audience question better. I'll see if I can get the first poll question launched for you. So if you can, it's a multi-choice question where you can respond on how the cloud resource is currently contributing in your monthly billing. And we have some responses already now. Okay, it's very interesting. Almost all three options have some significant impact. Mainly the computing workload seems to be the major one. I'll end here and we'll get to the next question. So the next whole question is to select which of the strategies you are considering for optimizing the cost currently. Interesting. The unused resource and the right sizing seems to be the most preferred one. So I'll move to the third and the last one. And if you can comment, what describes your need in terms of scaling up your team further in the process of taking your cloud journey ahead. So it's whether the development of your cloud features, or it could be managing your production, it could be automation through the DevOps process, or overall, optimizing through cost and the current architectures. Again, it's multi-choice, so it could be all of these as well as some of these together. Okay. Very good. I think the overall cost seems to be definitely the key aspect, and including the development part. Okay, thank you for your response here. I'll end the poll for now. All right, so now it's time to get into some of the audience questions before we conclude. So let's see. There are already some interesting questions out there. So the first one, it's talking about scalability. So since we haven't talked about scalability, does the scalability impacts the cloud cost? Maybe Abhijit, you want to?
Sure. Yeah. So when we talk about scalability in cloud, we can think of two possible options. The one is the horizontal scaling, which we can call it as scale out or scale in. Or even the other option is the vertical scaling, wherein we will increase the resource size, so scale up and scale down. Now, in both these cases, I feel the elasticity of each of the method comes into the play when we talk about optimizing the cloud cost. So we did mention about one of the key strategies being the right sizing, and that is definitely an effective way to managing the cost because it ensures that we have the resources provision with the optimal consumption. And while provisioning, I would say one more care we need to take care of it. We don't, provision it. We don't kind of under provision it.
Okay, yeah, makes sense. Maybe let's quickly check next question, and that's about hidden costs. So yeah, I think each providers, we need to have a good deeper knowledge about how we are subscribing to services. So do you see there are any hidden costs, and what are those?
Right. So when we talk about the cloud costs, like in terms of the provisioning of resources, we all know that we have the on-demand type of a provisioning. But then, like once we provision a resource, it is very easy to leave something in use for a longer than which is expected. So like do we say that in case of cloud pay for what you use, so the pay as you model which says like pay for what you use. In addition, we also need to consider like pay for what you provision. So when we say that like in terms of even if we have certain resources which are provisioned but which are not running or not getting used, still they may contribute to the cost, and those can be considered as one of the element of the hidden cost. The other scenario could be in case of storage type of resources, where we may have certain orphan snapshots. So even those will definitely contributes to the cost.
Right, yeah. Okay, so maybe let's take one final one. Um, okay, so this is about selecting the cost optimization strategy. So how to know which cost optimization strategy is right for my organization?
Okay, so let me say, in a way that whatever strategies that we talked about, so those are not mutually exclusive. Okay, and it totally depends upon understanding what your business or organization wants from the cloud. So if we could actually analyze the historical cloud spend along with the forecasting for the future budgets, that will help us in coming up with our or defining our own strategies. Now, having said that, certainly the priority would be there in terms of, let's say, if we are going with a strategy wherein we want to ensure that right sizing is something we do prior before we go ahead with the option of reserve VM instance.
Okay. Okay, sounds good. So maybe I think we'll pause here. And so thank you everyone for your interesting questions. But maybe with the time limit, we'll address the rest of those other questions offline. And I'm sure you all have enjoyed the sessions and it was insightful for you as well. So we touched upon many aspects on the cost optimization, and you probably have some got key takeaways to start on it. So before wrapping it up, let me just quickly just brief you about Harbinger Group. So we are established in 1990, so it's more than 30 years we are in the business, having customer base across the globe. We have about 800 plus engineering team operating dual shore in India and USA. Harbinger Systems is the technology services arm of the group, primarily focusing on end-to-end product engineering services for HR tech, EdTech, and health tech verticals. Harbinger Knowledge Products, focusing on integration-ready products like Raptivity and Quillians. And we have a content services division, Harbinger Interactive Learning, which focuses on custom digital learning and content transformation solutions. So for more information, write to us on hsinfo@harbingergroup.com. And so thank you, Abhijit, for a very insightful conversation today. And thank you everyone for joining us, and stay tuned for the next episodes. Thank you.